Soilcast. Boden, Umwelt, Klima.
Earth, as we know it, would look very different without weathering. In fact, the land surface would only be covered with rocks if it weren't for the fascinating processes of weathering that once started to transform the land to the landscape as we know it today. Since weathering is so important for soil formation, I would like to dedicate at least 2 episodes to this process. So what is weathering exactly? Perhaps some people think of weathered rocks as an old stone statue in the park, or an old house facade with cracks and discoloration. And that is exactly what we mean by weathering in soil science and geology. Weathering is the destruction of rocks and minerals by natural environmental influences. Do you know the difference between rocks and minerals? Minerals are materially homogeneous, like quartz, whereas rocks usually consist of several minerals. For example, granite is a rock, contains quartz, feldspar, and mica as minerals. But now back to weathering. Behind this perhaps somewhat bland term, there are incredibly exciting processes that are indispensable for life on Earth as we know it. Weathering enables soil formation through the physical crushing and chemical alteration of rocks. These weathering processes can be divided into 2 groups: physical weathering and chemical weathering. Physical weathering occurs without chemical changes to the rock or minerals. The rock is broken down mechanically. This means that the rock is simply crushed into smaller particles, but the chemical composition and minerals in the rock do not change. In chemical weathering, this is different. There, chemical processes are at work. These involve interactions between the minerals with water, air, acids, and organic compounds. As a consequence, the rock can change color. Chemical weathering changes the chemical state of a rock or a mineral. Physical weathering usually precedes chemical weathering, as it is responsible for crushing large rocks. The smaller the particles become, the more surface there is for chemical reactions to occur. In this episode, I would like to focus on physical weathering. Let's take a look at a few of these processes. A good example is thermal expansion. Most people know that substances expand when they heat up. This is because the atoms that make up the substance vibrate more if they have more energy, and they take up more space. When something is very cold, the movement of the atoms is much less, so they take up less space and the substance takes up less volume. This phenomenon is called thermal expansion. In everyday life, visual examples of thermal expansions are hard to find, but you can see proof of it when crossing a bridge. On bridges, there are so-called expansion joints, which help the bridge expand by several centimeters on warmer days. Without these expansion joints, cracks would form in the bridge due to thermal expansion, and it would eventually fall apart. This is exactly what happens with rocks. When the sun shines on a rock, it gets warm on its surface and thermally expands in this area. As the rock does not conduct heat particularly well, it takes a while for the heat to reach the interior of the rock. At the end of the day, the sun sets and it gets cold again. The outer material now cools down and contracts again, but on the inside the rock is still warm and expanded. This temperature difference leads to a constant tension between the outside and the inside of the rock. This effect is taken to the extreme when the rock is made up of minerals with different reflectivity, also known as albedo. Dark minerals reflect only little light, which is why they are dark. Since they have a low reflectivity, they have a low albedo. On the other hand, white minerals have a high reflectivity of light, and therefore a high albedo. The albedo of a material has consequences on how quickly a material heats up in summer. Black materials reflect less sunlight and therefore more energy from the sun can go into warming up the black material. You may have noticed that wearing a black shirt in summer heats you up much quicker than wearing a white shirt. In rocks with black and white minerals, the different heating of the minerals leads to different degrees of expansion. Granite, which contains black and almost white minerals, is very susceptible to physical weathering, as the 2 different albedos lead to different expansions under sunlight. This results in strong compressive and tensile stress. But how much stress are we talking about? If the temperature difference is 50 degrees Celsius, pressures up to 50 megapascals can occur. And that's a lot. 50 megapascals correspond to 500 bars, and 500 bars is what you find at a water depth of 5 kilometers. This enormous compressive and tensile stress causes cracks and fragments to form. The originally compact rock is crushed further and further until finally, a layer of loose material has formed on the outside of the rock. This loose material has a thermally insulating effect, which means that the temperature differences are not as strong anymore and the strength of the physical weathering strongly decreases. There is another very simple and important process of physical weathering: frost weathering. When water freezes, it forms crystal structures, which increase its volume by around 10%. If this happens on the surface of a rock, this does not have a weathering effect. But if there are cracks in the rock, even if they are very fine, the water can flow in a liquid state and freeze in the crack. The increase in volume of 10% already has some effect on the rock, but there is another process that intensifies frost weathering even further. Ice is dry, so to speak, and attracts water. You could say that ice crystals virtually suck in the nearby liquid water. This absorbed water attaches itself to the ice crystal, making it bigger and bigger. This process is called ice segregation. The volumetric expansion of freezing water can reach 200 megapascals. If there were an ocean with this depth, it would correspond to a water depth of 20 kilometers. Of course, this is difficult to imagine. Whether you can imagine it or not, it is clear that frost weathering has enormous effects and it is the greatest force of physical weathering. We are not going to discuss all physical weathering processes in detail, but let us briefly outline which other phenomena exist. There is salt weathering, which works in a very similar way to frost weathering, except that it is not water that crystallizes, but salts from aqueous solutions such as calcium sulfate. While the principle is the same, salt weathering is nowhere nearly as strong as frost weathering. Another form of physical weathering is root blasting. You may have seen this on roads. First, roots grow into small cavities where they fit. Then, the roots grow in thickness and the internal cell pressure of the root is so strong that the rock can become fissured. There are other processes such as intracrystalline swelling, osmotic swelling, and abrasion. There are even more forms of physical weathering, but these only play a minor role. Therefore, we can safely say that you now have a good understanding of the various processes behind physical weathering. To wrap up this episode, I want to highlight where on the planet physical weathering is the strongest. We have seen that weathering caused by thermal expansion is strongest when there are high temperature variations throughout the day. Deserts are characterized by high temperatures during the day, followed by a strong drop in temperature as soon as the sun sets. Rocks that contain black and white minerals, such as granite, don't last long in such an environment due to the different degrees of expansion as the minerals heat up at different rates during the day. The form of physical weathering that is even stronger than thermal expansion is frost weathering. Of course, frost weathering only occurs in regions with temperatures cold enough to form ice. However, frost weathering is not strongest where temperatures are lowest, like in Antarctica, but where temperatures are often around the freezing point of water, for example in cold coastal climates. Since weathering is very important for soil formation, this information about where each weathering process is strongest will help you to understand the soils found in different regions and climates around the world.
Der Soilcast ist für euch kostenlos und das soll auch so bleiben. Ihr könnt uns dabei helfen. Derzeit unterstützen uns etwa 1% unserer Zuhörerinnen und Zuhörer, zum Beispiel durch eine kleine Überweisung auf das Geschäftskonto oder via PayPal. Wie das genau funktioniert, seht ihr auf soilcast.de unter dem Punkt Unterstützen. Das Geld wird für die digitale Infrastruktur verwendet und darüber hinaus in Technik investiert. Vielen Dank für eure Unterstützung.